Mineralogy N1 is a subject of geology specializing in the scientific study of the chemistry, crystal structure, and physical, including optical, properties of minerals and mineralized artifacts. Specific studies within mineralogy include the processes of mineral origin and formation, classification of minerals, their geographical distribution, as well as their utilization. An initial step in identifying a mineral is to examine its physical properties, many of which can be measured on a hand sample. These can be classified into density, often given as specific gravity, measures of mechanical cohesion, hardness, tenacity, cleavage, fracture, parting, macroscopic visual properties, luster, color, streak, luminescence, diaphaneity, magnetic and electric properties, radioactivity and solubility in hydrogen chloride, HCl. 597 to 113 8, 39 to 53. Hardness is determined by comparison with other minerals. In the Mohs scale, a standard set of minerals are numbered in order of increasing hardness from 1, talc, to 10, diamond. A harder mineral will scratch a softer, so an unknown mineral can be placed in this scale by which minerals it scratches and which scratch it. A few minerals such as calcite and kyanite have a hardness that depends significantly on direction. 9, 254 to 255 hardness can also be measured on an absolute scale using a sclerometer. Compared to the absolute scale, the Mohs scale is nonlinear. 8, 52. Tenacity refers to the way a mineral behaves when it is broken, crushed, bent or torn. A mineral can be brittle, malleable, sectile, ductile, flexible or elastic. An important influence on tenacity is the type of chemical bond, for example, ionic or metallic. 9, 255 to 256 of the other measures of mechanical cohesion. Cleavage is the tendency to break along certain crystallographic planes. It is described by the quality, for example, perfect or fair, and the orientation of the plane in crystallographic nomenclature. Parting is the tendency to break along planes of weakness due to pressure, twinning or exsolution. Where these two kinds of break do not occur, fracture is a less orderly form that may be conchoidal, having smooth curves resembling the interior of a shell, fibrous, splintery, hackly, jagged with sharp edges, or uneven. 9, 253 to 254. If the mineral is well crystallized, it will also have a distinctive crystal habit, for example, hexagonal, columnar, botryoidal, that reflects the crystal structure or internal arrangement of atoms. 8, 40 to 41. It is also affected by crystal defects and twinning. Many crystals are polymorphic, having more than one possible crystal structure depending on factors such as pressure and temperature. 5, 66 to 68 8, 126.